Alright, let's go ahead and talk about simple area. So I'm just going to go through basically one example of each of these, a square, rectangle, parallelogram, rhombus, and trapezoid, and we'll just talk about how to find the area of each. So in our very first example, let's go ahead and talk about a square. Alright, so let's say we have a square. We know that all four sides are congruent. That's the definition of a square. We also know that all four angles of a square are congruent. They're all 90 degrees. Now let's say that here we had a side that was 3 centimeters long. Well, we come over here, we say our formula for the area of a square is equal to the sides squared. And so we could say the area of this square will be 3 squared, or the area of our square 3 squared is 9 centimeters squared. Easy. Alright, let's move on to, and we're just going to skip a rectangle. A rectangle is the length times the width. But let's go to a parallelogram. Okay, what makes a parallelogram a parallelogram? Well, the opposite sides are congruent, okay? And you'll also notice that the opposite sides are also parallel. That's why we call it a parallelogram, okay? So, what do we know about these? Well, basically the formula for the area of a parallelogram is going to equal the base times the height. So here, let's say that we had a base of, let's say we had a base of 8 centimeters, and let's say that we had a height of 3 centimeters. You can almost think of the height as like an altitude. Well, what we would say is that the area of our parallelogram will be the base, 8, times the height, which I have here in blue, 3, and we could say that the area of our parallelogram would be 24 centimeters squared. Remember, anytime you're using area, any type of area, your units will always be squared. Okay, let's move on. Okay, here we have a rhombus. Now, what makes a rhombus a rhombus? Well, it's a parallelogram where all four sides are congruent. You can almost think of it like a tilted square. And how do you find the area of a rhombus? Well, you'll notice right here we could either use the parallelogram formula, the base times the height, or we actually have this other cool little trick. We can do 1/2 the diagonal 1 times diagonal 2. So let's say here this is diagonal 1, and then let's even use just a different color here. Let's call this one diagonal 2, okay? And let's say I gave you all this. Let's say I said, D1 is equal to 8, and D2 is equal to 12. So what would be our formula? Well, our formula is clearly going to be the area of a rhombus is equal to 1/2 D1 times D2, and in this case we could say 1/2 times diagonal 1, which is 8, times diagonal 2, which is 12. And notice from here I can just work it down. 1/2 times 8 is 4. 4 times 12 is equal to 48. Now, I didn't put any units here, so in this case we would simply say units squared. Alright, let's go on to our very final example of a trapezoid. Okay, so what makes a trapezoid a trapezoid? Well, it has one set of parallel sides, as you can see from these arrows. And let's see. What if I were to tell you that this trapezoid had a height of 4, and let's say that the top base, because really we call both the top and bottom bases, so let's call this top base. Let's say that this was 6 centimeters, and 4 centimeters, and on the bottom, let's say that it was 10 centimeters. So what would we say? We would say, our area of a trapezoid is equal to 1/2 B1 plus B2 times the height. And when I go to plug in everything there, I say, okay, let's call that 0.5 times our base 1 is 6 plus our base 2 is 10 times our height of 4. Now let's go ahead and do two things here. So next, we know that for the area of our trapezoid, multiplication is something that we call commutative. You can switch the order. So let's do 0.5 times 4. So what's 1/2 times 4? Well, that's 2 times. And here we have 6 plus 10, which is 16. And so then I can say, well, you know what, the area of my trapezoid, 2 times 16, is 32 centimeters squared. Alright, I hope this helps, and I'll see you guys in our next lesson.